Hello humans! I was looking for smaller keyboard and Planck got my attention. However, the waiting times were almost infinite. After that, I stumbled upon the Levinson from the Kailh, or also known as Let's Split, and I immediately decided to give it a try. In this video, I will show you the build process of this Levinson keyboard. Here are the parts that I chosen for this build. First, I got the Kailh Noble Yellow switches. These are cherry style clicky switches with actuation force of 65 grams and the bottom up force of 50 grams. These switches feature box design, same as the box whites or box jades, and parameter wise these Noble Yellows lie somewhere in between them. For the Levinson build, 48 pieces are needed. For the caps, I decided to go with the XDAs, which are my favorite. Got them in blank and in various colors. Again, 48 pieces are needed, all of them in 1U size. Then I have the Levinson kit from the Keep.io, which comes with 2 PCBs, diodes and plugs. Two Arduino micros which can run the QMK firmware. If you do not want to use the USB micro connector which Arduino has, good alternative is Elite-C from the Keep.io, which features USB-C connector, but also Elite-C is significantly more expensive than the Arduino. Important part is 3D printed case, which I printed from Devil Design PETG, raspberry color for the top and the PC gray color for the bottom. The original designer of this case is Zuckerworks from the Thingiverse. My PCB didn't fit the standoffs well, so I decided to remove them, and also I decided to remove the screw holes for a little bit cleaner design. My design will be available on the Thingiverse as a remake. This case is designed to use 8mm rubber feet. Audio cable for connecting the two halves together. This particular one turned out not to be working because it's only 3-prong. You actually need the 4-prong jacks. And for the last part, the USB cable, I have this 3-meter long coiled one, which is great because it saves so much space on my desk. First thing in the assembly is to solder diodes, TRS jacks and pin headers to the PCBs. Arduinos and the switches will be soldered once the PCBs are mounted in the cases. It's good to prepare the diodes by bending their legs, because it will be easier to insert them into the through holes on the PCB. Diodes are soldered on the bottom side of the PCB because it will be easier to replace them in case one of them has a failure. For now, you don't need to care about what PCB is left and what PCB is right because they are identical. So solder the diodes on one PCB one way and the other PCB the other way. When inserting the diode, the black end faces the square. All diodes are oriented vertically and the black end is always facing the bottom. There are 24 diodes on each PCB, each one for one key. However, keep in mind that there are not the same amount of diodes in each line. First line has 5 diodes, next one 7, 7 and last one 5. I like to solder them line by line because it seems to be less prone to the mistake. After soldering is done, the legs can be clipped off. Now the first PCB is done, so let's repeat the process on the other PCB. Keep in mind that now the diodes are soldered on the opposite side. TRS jacks are soldered the same way. When soldering headers, you need to cut them shorter in order to fit in the case. After that's done, you can solder them on the same side as you soldered the diodes. And keep in mind, do not solder the Arduino micros yet. When securing the PCB in a case, I put 4 keys, one in each corner. Switches are fitted with the holes facing down and the pins facing top. And the PCB is carefully inserted so that switches fit the PCB and the switches do not pop out of the case. And after those 4 are soldered and secured, the rest of the switches can be inserted as well. I find this to be the most satisfying moment of the build. Before soldering, always make sure that none of the legs are bent. In my case, I found one switch with bent leg. It's all good to cut the 2 switches which are on the Arduino micros so you don't short it out. And then the Arduino micro is soldered. Here I have the left side, so the Arduino micro is soldered with the USB port facing the PCB. On the right half, it's soldered with USB port facing away from the PCB. At this point, the keyboard should be fully working. You can flash the firmware, connect the cables and make sure that every key is working. Bottom panels on the original design of the case were attached using screws, but since I got rid of the standoffs, I also got rid of the screw holes, so you need to use the glue in order to attach the panels. In my opinion, this is also leading to the cleaner design. The glue I will be using is called B7000. It's a cheap glue used to attach the phone screens. The case can still easily be disassembled by heating it up. Okay, and the next step is putting on the keycaps on the keys. And the keyboard should be fully working now. Let's plug it in and see it working. I love the sound of these knob yellow switches. The click sounds and feels heavier than the standard blue switches, and even the tactile feeling is more defined. LED Split / Levinson is the nice small portable keyboard with the same profile as the Planck. Actually, I ordered the parts for this keyboard because I got tired of waiting for the group buy of the Planck. And this is actually the second Levinson I built. I really like this split design because hands are further apart, meaning they are less stressed compared to the Planck or to the standard keyboard layout. The only downside is that you need to carry the extra audio cable to connect the two halves together, however that's not that big of a deal. And after using this keyboard for a few months, I can say that so far this is my favorite keyboard and I will be selling my Planck. Thanks for watching this video, I hope it was useful for you. If you have any questions, ask them in the comments. I'm expecting to build few more keyboards in the future, so you might consider subscribing if you like this type of content. Okay, see ya, ciao!